Okay, so this is lesson 1.5, and we're going to go through and fill in the unit circle. Now, I got a lot of different feedback from my second period on how they filled it in. So, any of you guys want to run by me, like how you guys did it for your 30, like how you figured out? Well, first off, let's do the easy part. This is 30 degrees. Do we agree? That's 30 degrees. This one is 45 degrees, and I'm looking for one of my, just turn it. 45 degrees. And this one up here is what? 60 degrees. All right, and when we get to filling them out as radians, this would be what? Pi over 6. 45 is pi over 4. And 60 is pi over 3. Okay, let's just fill in quadrant 1 first, since this is review from yesterday. Do you agree this would be the triangle here? It's a right triangle, and this theta here is 30 degrees. Okay, this is the long side, this is the short side. Is the long side 1/2 or root 3 over 2? So root 3 over 2, and the short side is what? 1/2. All right, here's the 45. Another right angle. I'm not going to mark it, but that in there is a 45-degree angle. What's nice about a 45, 45, 90, these legs are what? The same. And I write mine as 1 over root 2. If you write yours as root 2 over 2, because that's the way your last year's math teacher taught you, is that okay? That is perfectly fine. All right, and 60 degrees finally is pi over 3. And if I were to draw my triangle here, again, I'm not going to mark it, but this big angle here is 60 degrees. And this is the long side or the short side? We talked about it yesterday. This is the short side, and this is the long side. So what goes in the x value where the short side is? 1 over 2, and this is root 3 over 2. All right. Is this pretty much review of what we did yesterday?
Yes.
Yes. Okay. Questions before we move on? All right. Any of you guys want to share how you figured out these, like radians or these degrees? Is there a little shortcut that you've used?
Not on the 45s, but it's every like 30 and 60 increments. It's like pi over 6 and then 2 pi over 6,
Good.
3 pi over 6.
Good. Okay, so that's what my morning class said. She's saying, don't count the 45. What's 30 plus 30? And what's 60 plus 30? And what's 90 plus 30? 120. And what's 120 plus 30? Okay, so we're not counting the 45. So let's put the angles in there first. You guys said this one was 120. And you said this one was what? Plus 30, 120 plus 30 is 150. Okay, now take a look at it. Do you guys agree if I were to draw this down here and I were to ask for what this reference angle is, you would do 180, take away 120, and what would you get in this little angle here?
60.
And does it match this blue triangle over here?
Yeah.
Mm-hmm.
Yes? So are these numbers going to flop over here as well? 1/2 and root 3 over 2. What's going to be the difference?
Negative 100.
Negative 1/2, because it's negative short side, positive long side. Do you guys see that? We'll fill in the radians in just a little bit. I'm going to go ahead and go to this one here. Can you guys see that if I did 180 minus 150, what would I get here as my reference angle? What is it? 30. And is that the same as this pink one here? So root 3 over 2, comma 1/2, which one's negative? Because that is the x value, and this x value is negative. All right. Let's go ahead and get our radians. Now, she was saying they move in increments of 30. So let's see if the pattern works. If this is pi over 6, what's 30 plus 30 is 60. What's pi over 6 plus pi over 6? 2 pi over 6. And is this equivalent to 2 pi over 6? Yes? And what's 2 pi over 6 plus another pi over 6? And is that equivalent? Yes? And what's 3 pi over 6 plus another pi over 6? 4 pi over 6. And can I reduce that? What is it reduced to? 2 pi over 3. And so that's how you get that radian there. So what she said is you count in increments of pi over 6. And don't count the 45. 1 over 6, 2 over 6, 3 over 6, 4 over 6. So ignoring the 45, what would it make this one? 5 pi over 6. And can I reduce that one? Okay. Does that make sense? All right, let's get the 45s down really quick. This reference angle, is that green for me? This reference angle here is 45 degrees. So how would I find it? 180 plus 45 or 180 minus 45? Minus. And you either have it memorized from last year or you're doing it in your head right now. What is it? 135. And can we do the same pattern? What's 45 plus 45? 90. And what's 90 plus 45? And what's 135 plus 45? Okay, so let's see if we can use this same pattern, different fraction. This is 1 over 4. This would be 2 pi over 4. Is that equivalent? Which would make this one what? 3 pi over 4. And this would be 4 pi over 4. And is 4 pi over 4 equivalent to pi? All right, so do you guys see how we figured all that in? Yes? Now, I'm not going to put these numbers in down here because technically is quadrants 2, 3, and 4 the exact same thing as quadrant 1 replicated over with just the signs changing?
Yes.
Yes. Yes.
So on quadrant 2, I have like the 2 pi over 2, 3 pi over 4.
Mm-hmm.
I'm confused as to how you got those, but like I do understand how like you use the counting method.
Mm-hmm.
I don't know how you have like
Okay, like why this one's over 3, 4, and 6?
Oh, I know, no, never mind, yeah, my bad.
Okay. Okay, well, I'm glad you said it because I do want to bring it up that these two in pink, do they have the same denominator? So anything that has a denominator of 6 will have a reference angle of pi over 6 or 30 degrees.
Yeah.
Anything with a denominator of 4 will have a reference angle of pi over 4 or 45 degrees. And anything with the denominator of 3 will have a reference angle of 60 degrees or pi over 3. Does that make sense?
Yeah.
Okay. I didn't fill this one in. What should it be? Negative root 2 and positive 1 over root 2, or if you're using your root 2 over 2, you fill those in. Okay. I do want to fill in the degrees and radians. Before I do that, I'm just going to put plus and minus plus signs. Here, are ones negative or both are negative? Both. So I'm going to put negative, negative. And what about here? X is positive, Y is negative, so positive, negative, positive, negative, and positive, negative. Okay, I will put the degree measurements and the angle measurements. So let's do this one first. We agree this was increasing by 30. 30 plus 30 is 60. 60 plus 30 is 90. 90 plus 30 is 120. Plus 30 is 150. Plus 30 is 180. Plus another 30 is what? 210. Plus another 30 is what? 240. Plus another 30 is what? And do we have the 270 already? Plus another 30, I'm over in this quadrant now, is what? 300? And I don't have to put the angle markings, they're already there for me, sorry. Okay, so I'm at 300, and 300 plus another 30 is what?
330.
330. Okay. 45? 45, 0 plus 45 is 45, plus 45 is 90, plus 45 is 120, 135, plus 45 is 180, plus another 45 is what? 2 what?
225.
225, plus another 45?
315.
315. All right, now let's see if we can use that same pattern with the radians. So let's see where we were at. We had 1 over 6, 2 over 6, 3 over 6, 4 over 6, 5 over 6, 6 over 6. This would be what? 7 over 6. I'll go ahead and write that in pen. 7 pi over 6. Keep going. This would be what over 6?
8 over 6.
8 over 6. Does that reduce? What is it? 4 pi over 3. Okay, so 8 over 6, this would be what? 9 over 6. Does that reduce to 3 over 2? Plus another one would be 10 over 6. Does that reduce? What is it? 5 pi over 3, and we're going to keep going. 10 over 6, this would be, does that one reduce? So 11 pi over 6. And the next one would be what? Plus another pi over 6 would be 12 pi over 6, and does that reduce to the 2 pi?
Yeah.
All right, and let's get the 45. 1 over 4, 2 over 4, 3 over 4, 4 over 4. What would this one be? 5 pi over 4. 6 pi over 4. Does that work for 3 over 2? And then this one would be what? 7 pi over 4. Okay. Make sense?
Are you doing like the over 4 thing? Like 7 pi over 4, and like if you backtrack and you had the 5 pi over 6 over there, you got that by reducing? Or
Option 3.
yeah.
Put 5 pi over 6 instead of 5 pi.
Oh, right here. That was going too fast. Thank you for catching that very much. Okay, that was just me going too fast. 5 pi over 4. All right, are we good? Okay, so let's quickly fill in this positive, negative. Looking at sine, cosine, and tangent, what's positive in quadrant 1? Everything. I want to put all. And what's negative? None of them. Okay. Sine, cosine, and tangent. Let's look at the x values. What's positive here? The x values or the y values? And y is sine or cosine? Sine. Is cosine positive or negative? Negative. And what about tangent? If tangent's y over x, positive over negative is going to be negative. So the only thing positive is sine, and here it is all. Okay, so far so good?
Isn't there like an acronym?
We're going to get to it. You're right, we will. Okay, here, what's positive? Well, let's go off what's negative first. What's negative?
Sine and cosine.
Sine and cosine. And what is positive?
Tangent.
Tangent. People will say nothing. Well, tangent is, right? Because a negative over a negative is a positive, right? And then this one is x or y that's negative. Y, and y is what? Sine? Sine is negative, which means what's positive in here, in this case? Cosine. And where is tangent if it's negative over positive? Positive or negative? Negative. Okay, so what's the only thing positive? All right, so here's the acronym that some of you may have learned yesterday. A for all, S for sine, T for tangent, C for cosine. All students take calculus. All right, so yes, you can remember that. All students take calculus. I know there's other schools that say all sad turtles cry. Don't know why, but that's what they have. But all students take calculus. Or all sad turtles cry. All right, questions on this before we move on? Okay, how many of you did the 3, 2, 1, 1, 2, 3 trick last year? Okay, if you did that last year and it worked for you, can you still do that? Yes. How many of you made a chart and just fill in the chart, and that chart helped you. I know Cabose's class kids that they did, like, I don't know, they had a chart.
We did a lot of like quadrants. Like we had quadrants for each, like 45, 30, 60, and then like each quadrant had its thing. But we had like a bunch of them.
Oh, okay.
So like one for
Okay.
radians, one for degrees.
Okay, yes.
When I was in Math 2 honors, I just printed out a whole bunch of charts and then filled them out until I knew it.
Okay, so but like, like what kind of charts?
Like these ones, I just took blank
Oh,
ones of
okay.
these and I just kept filling them out.
So yes, you can get these blank ones. You can find blank ones online. And she said she just filled out a bunch of them until she figured it out. And that works. Okay. But I would like to point out, do you guys agree that quadrant 1 just replicates in every quadrant, just signs changing? So if you have quadrant 1 memorized, would that help you for all 4? Yes? So technically, do you have to have the whole thing memorized? No, you should know, like 5 pi over 6, you should know that it has a reference angle of pi over 6 because the denominator is 6. 5 pi over 4, you should know has a reference angle of pi over 4. Why? Because the denominator is 4. 4 pi over 3 has a reference angle of pi over 3 because the denominator is 3. And same thing in these quadrants. That you should know. Okay. I'm going to show you a trick. Now, this trick isn't like, not for all. Some of you won't like it. Some of you will. How many of you learned the multiply by 9 trick when you guys were kids? Yeah? You guys remember that? 9 times 7, 6, 7 is 63. Do you guys remember that? Yeah. 9 times 8, 6, 7, 8 is 72. Yeah? All right. Same kind of concept. It kind of works that way. It only works for 9s. Yeah, somebody asked, well, how do you do 3 times 5? It only works for 9s. 3 times 5, 5, 10, 15. I don't know what else to say. All right. Okay, guys, listening. Now this trick, why do some people like it? Because they no longer have to use this. Now, those of you that use the 3, 2, 1 and 1, 2, 3, you have to make up this chart every single time, right? And that's fine. Now, you don't want to be at the end of the semester and still be dependent on the unit circle. We want to baby steps now, but by the end of the semester, we want to have most of this stuff memorized. Got it? So this trick helps with that. You don't need the unit circle as much. Now, when you're doing homework today, you may think, well, it's easier for me to just look at this than use the hand trick, which might be true. But in the long run, what's going to be easier? The hand trick, rather than looking at this every time, because you're going to need a unit circle every time you work on trig problems. All right, you ready for the trick? Okay, put your left hand out in front of you. Left hand. Everybody have it out? Now I had to draw it because I need to put numbers down. So this is, I'm pretending is my left hand. All right.
Draw it on the back of the circle.
Yeah, if you want to. But I want you guys listening first, and at the end you can put notes in if you want. Okay. It's always going to be root something over 2. Oh, and before I go any further, I'm going to pause here. Should you guys have this memorized, that 1 over root 2 is equivalent to root 2 over 2? Should you just flat out know that? Yeah. Yes, because I write it this way, the book writes it this way, and some of you write it this way. You should be able to go back and forth fairly quick. All right, so here is how it works. Yes?
You can also just use your right hand, but like this.
Yes, you can. Yes, so instead of doing this, he's saying, can you do this? Yes, if you want. All right, so, now you made me forget what I was going to say. Oh, here it is. Let me put my hand up here now. Oh, you can't see that. Okay, so this is going to act as the 0. This is going to act as the 90. 0, 90, or 0 and pi over 2. This is going to be the 30, 45, 60. Do you see that? What is this one? 30?
45, 60.
So now let's do it as radians. 0 radians, pi over 6, pi pi over 4, pi over 3, and okay. Now, typically I don't use it for the 0 and the 90. You can, but for me I just use my ordered paired 0, 1, or 1, 0. And typically I don't use it for the 45 either. Why? Because 45 is pretty easy. What sine of 45? And cosine of 45. Are they both the same? Yeah, and what's tangent of 45? 1, right? All day long, it's 1. Okay, so I don't use it for the 45, but the 30 and 60 is where you're going to want to use it. So I'm going to do this for the pi over 6 first. Okay, so you put that finger down. So imagine that this finger is down. Okay, so if I put this finger down, anything here is going to be the x, and anything at the bottom is going to be the y. X, y, which means cosine, sine, right? Because cosine is the x. All right, so what's the x? 3, so it's root 3 over 2, root over 2. This is going to be what? 1. Root 1 over 2. What's the square root of 1?
1.
Is that the same as just 1?
Yeah.
All right, so root 3 comma 1/2. And is that the ordered pair that we have here for the 30? Yes? Okay, so we're going to try it here, and then we're going to talk about where and how you can use this. Okay, so let's pretend this finger is back up and this finger is down. And it's root blank over, no, root blank over 2, root blank over 2. This is x, this is y, or cosine and sine. Okay, so this finger is down. This is x, this is y. What do I have under the root for the x? 1. Root 1 over 2, and for the other one? Root 3 over 2, and the square root of 1 is the same as what? 1. Do you see that? Yes? And is that the ordered pair that we have here? Okay, so where is this going to come in handy once you master it? Is when you're doing homework and you have, let's say, sine of 7 pi, no, I'm going to pick a different one. Sine of 11 pi over 6. All right, first thing you're going to do is say, okay, pi over 6. This is 0, this is 90. Of these 3, which one's pi over 6? First, second, or third? First, because that's your pi over 6, pi over 4, pi over 3. You put it down. Sine is x or y? Y. So I'm going to be down here. So is it root 3 over 2 or 1 over 2? 1 over 2. And you did not need your unit circle. Now, the only thing you have to be careful is it positive or negative. So you do this. All students take calculus. Which quadrant is 11 pi over 6 in? Fourth, only cosine's positive, so what is this? Positive or negative? Negative. And we did not need the unit circle. So do you see how, if you mastered and you become really good at it, it will help you rather than having to use this every single time? Yes? Now, I would suggest that when I get the worksheet out, there's like 52 questions, and kids are like, oh my gosh, but it goes really quick. I suggest that you try at least some of them using the hand trick, even though you feel like it's so much easier just to look here. In the long run, you don't want to become dependent on this for every single test that we take. Got it? I had some kids try it, and over time they did get better at it. Any questions on the hand trick? Oh, and why do I not use it here? Let's try one of those. Let's try tangent of 7 pi over 4. And I'll even try cosine. Cosine of 7 pi over 4. What's my reference angle here? Come on, guys. Denominator's 4. What's my reference angle? Pi over 4, right? And without even thinking about it, what's cosine of pi over 4? 1 over, or root 2 over 2, depending on how you write it. And what's tangent of pi over 4? 1. The only thing we have to do is come here. Which quadrant is 7 pi over 4 in? Fourth. And what's the only thing positive? Cosine. So what do I put on the tangent? Positive or negative? And what do I do with the cosine, positive or negative? Positive. Okay, so does that make sense? Yes?